In this video, we're going to go over how to write the chemical formula of ionic compounds that contain now polyatomic ions. Okay, so what we're going to need to know, we have to remember all the charges of the monatomic ions. They come from the periodic table, and polyatomic ions are ions that have multiple atoms, and they're found in our reference sheet. Okay, so you should have a link to the reference sheet. We're also going to have to remember that when ions come together, when these atoms that have charges, when they come together to form a compound, an ionic compound, the charge is now neutral. They don't have a charge anymore. All right. So let's take a look at our first practice problem here. In our first practice problem, we have calcium nitrate. So the polyatomic ion here is nitrate. Notice that it doesn't have an IDE ending. Okay. So just kind of remember that. So let's figure out the charge of both the calcium ion and the nitrate ion. So let's look at our periodic table. Calcium is right here. Calcium has a positive 2 charge. Try to remember that. Then we have our common ion table. We're going to look for nitrate now. Nitrate is right here on the bottom. It has a negative 1 charge. It's NO3. So it's NO3 and has a negative 1 charge. Try to remember that too. So we're going to go ahead and write this down now. Calcium, positive 2. Nitrate is NO3, has a negative 1 charge. Do these charges cancel out? They do not. We're going to need another negative ion. So let's write the nitrate again. So now we have a total of negative 2. We have a total of positive 2. They cancel out. We can go ahead and write our formula for this, our chemical formula. Now in our chemical formula, there should be 1 calcium ion. However, 2 nitrate ions. Okay, 2 nitrate ions. So let's write it down. Now when you first write it down, you might write something like this. However, when we write this, this is actually wrong because there is not 32 oxygens. Okay, we're trying to say that there are 2 nitrates. So to make sure that we write this correctly, we want to write parentheses around the nitrate, and then you write the 2 as a subscript. All right, so there's 2 nitrates. Let's go ahead and look at another practice problem. We have ammonium nitride here. So ammonium is going to be our polyatomic ion. Just a heads up. Nitride we can find on the periodic table. We're going to find the charge of ammonium and also nitride. So let's go and find on the periodic table, here's nitride. Nitride has a negative 3 charge. Try to remember that. Next, we're going to look at the common ion table, and we're going to search for ammonium. Ammonium is on the top. Ammonium's on the top, and it has a positive 1 charge. So it's NH4, and that has a positive 1 charge. So let's go ahead and list these. Ammonium is NH4 and has a positive 1 charge. Nitride, if you remember, is N and has a negative 3 charge. Do these charges cancel out? They don't. We're going to need more positives, so let's add another ammonium. If you take a look at this now, there's a total of positive 2 and a total of negative 3. We still need more positives, so let's add another ammonium. Now there's a total of positive 3 and a total of negative 3. They cancel out. Great, we can write our chemical formula now. So just know that there are supposed to be 3 ammonium ions and 1 nitride ion. So when we write our chemical formula, we're going to write something that kind of looks like this, except notice how it says H43. There's not that many H's. We want to make sure we say that there are 3 NH4s, 3 NH4s. So to correct it, we're going to put a parentheses around the NH4 and then follow it with a 3. So there's 3 ammonium ions here, only 1 nitride. All right, let's take a look at another problem. In this next problem, we have sodium carbonate. Carbonate is going to be our polyatomic ion here. So we're going to go and find the charge of sodium ion and the carbonate ion. Let's find sodium first. Sodium is on the periodic table, has a positive 1 charge. Remember that. We're going to go ahead and look at our common ion table to try to search for carbonate. Carbonate is on the bottom. It's right here. Carbonate has a -2 charge, and it's CO3. Okay, so it's a CO3 and it has a -2 charge. So try to remember that because we're going to list it. Sodium, +1. Carbonate is CO3 and it has a -2 charge. Do these charges cancel out? They don't. We're going to need another positive ion. So let's put another sodium ion. Now there's a total of +2 and there's a total of -2. The charges cancel out now. So we can go ahead and write our chemical formula. Just know that there's going to be 2 sodium ions. There's only 1 carbonate ion, right? So when we write it down, we're going to say something like Na2CO3. In this case, this is the answer. We're not going to need a parentheses around our carbonate ion because there's only 1 of them. Okay, so try to remember that. If there's only 1 of your polyatomic ion, you will not need a parentheses. If there's more than 1, that's when you do need parentheses. Okay, let's take a look at our 4th example problem. We have ammonium phosphate. Ammonium is a polyatomic ion, and phosphate is also a polyatomic ion. So we're going to find those, not from the periodic table. You can't find those from the periodic table. You're going to find both of them on the common ion table. Ammonium, if you recall, is right here, NH4, and it has a +1 charge. And we're going to look for phosphate. Phosphate is on the bottom. It's PO4 and has a -3 charge. PO4 and has a -3 charge. Just remember that and list these. Ammonium is NH4, +1. Phosphate, PO4, -3. Do these charges cancel out? We have +1, -3. They don't. We're going to need more positive now. So let's add another one. Now there's a total of +2, -3. Still doesn't cancel out, so we're going to need more positive again. Let's put another ammonium ion. Now there's a total of +3 and -3. Now they cancel out. So we're going to go ahead and write this formula down. Just know that there are 3 ammonium ions. Oops, changed purple for some reason. There's 3 ammonium ions. There's only 1 phosphate ion. Okay. So when we write it down, it's going to look something like this. Looks a little bit awkward because it's saying again that there's 43 ammoniums. That's not right. We're trying to say that there are 3 ammoniums. 3 ammoniums. So we're going to put a parentheses around NH4. Right? The PO4 does not need a parentheses because there's only 1 of those polyatomic ions. All right. I think there might be one more example here. This is going to be our last example. We have magnesium phosphate. The polyatomic ion here is our phosphate. Magnesium, we're going to need another charge of that anyways, and then we're going to find phosphate's charge. So on the periodic table, magnesium's right here, has a +2 charge. Remember that. We're going to look at the common ion table now for phosphate. Phosphate, if you recall, is right here. Phosphate is PO4 and it has a -3 charge. Try to remember that. Let's go ahead and list them. Magnesium, Mg, +2 charge. Phosphate, PO4, has a -3 charge. Do these charges cancel out? They don't. We're going to need more positive, so let's add another magnesium ion. Now there's a total of +4 and a total of -3. They still don't cancel out, so we're going to need more negative this time. Now there's a total of -6 and a total of +4. They still don't cancel out. We're going to need more positive. So let's add another magnesium ion. Now there's a total of +6 and a total of -6. Great. They cancel out now. We can go ahead and write the chemical formula. We just need to know that there are 3 magnesium ions. There are 2 phosphate ions. Okay, so let's go ahead and list these. So we have here Mg3PO4 2. However, it looks like there's 42 oxygens here, which isn't the case. So we're going to go ahead and put a parentheses around our phosphate, the PO4. So to correct it, we're putting a parentheses around there. Now it looks more like there are 2 phosphates, which there are supposed to be. All right? Okay. So you can go ahead and try your practice problems now. And if you need to take a look at the key later, you can look to check for accuracy.